Hi everyone, this video is to show how my final project for Mechatronics class, the Omni directional rovers for material transportation, works. In the following seconds you will be seeing the screen of my computer where you can be seeing the server or the MQTT server broker that manages the communications between the Python programs and the MATLAB programs and the Arduino itself, that is handling the communications through the ESP32 board. So here now in the computer screen, here we have three different windows. The first one is the terminal in white color that is handling the server, the Mosquito server, that is pretty much creating an MQTT network over Wi-Fi using my computer and the port 9999 or 49s in order to allow different programs, like here on this black terminal or in the MATLAB terminal or even in the Arduino with the ESP32 module, to communicate. So here we can see that this broker not only handles the communication but also shows us a log of what's going on within, which new clients are connecting to the server or disconnecting to the server. Then we have on this black terminal an instance of Visual Studio Code where we are running two different programs in Python. One that is pretty much reading the MATLAB signals. As we will be seeing here, there is a sample that has the different steps or control signals that we are sending to the Arduino right now. And here on the left one, we are using a hello world, but that hello world is coming from the Arduino itself, wirelessly. This also will be handling the signals from the different sensors that the Arduino has. Ultimately, we have here the MATLAB terminal. This one handles the main code that is taking the trajectory that we want to send to the robot and translate those things into control signals that then we can stream to Python over a text file that we are modifying. This gap of modifying a text file that Python can read is being done because the MQTT library that MATLAB has is a little bit incomplete, so the communications were not that great. So that's the workaround that was made. Now, after pressing here F5, the whole process will start like this. Right here. It will start streaming the steps each one by one. Then we can see here on the network how is that being seen. And then in a few seconds we will see how the robot responds to that. Once the robot gets the last message that it will be at the step number 49 or actually 50, we can just press one button and it will start running, as we can see now. After we upload the code, we can see that the robot is ready to start. The only thing missing is that we need to press the yellow button, like we can see here. So after we tap this button and Arduino detects the signal, as we will see, we'll start. In this case, we uploaded the straight line path. Now we'll be testing a second path that will load it into the robot. So this path is a sine wave, as we will be seeing. First, we just need to hit this button. Sometimes the thing that will happen is that there is a buffer because the robot is trying to keep a specific amount of turns in each wheel. And that happens, and for some reason there is a drift in the amount of turns. It will get in an error state, or we'll be waiting to get to the amount of right counts. When it does, it will follow to the next step that is following, or that was sent by the computer. And now that we finished, the arm is just in a waiting state for the next path that we can upload.